3.7 Graph linear functions. Function notation. Recall from pre-algebra that we can write y as f of x. And this would equal to mx plus b. Okay, and the symbol f of x is another name for y and is read as the value of f at x, or as I was saying, f of x. It does not mean f times x. Any letter such as g or h can be used to name functions. Family of functions is a group of functions with similar characteristics. So, if I give you f of x equals mx plus b, you can come up with many types of equations following this format, and they will all look like lines, and we call that a family of functions. The parent linear function is the most basic linear function, f of x equals to x, which goes through the origin 0, 0. And for every y, it would every x, it will equal to y. Okay, and moving on. Changing m or b in the general linear function g of x equals to mx plus b creates families of linear functions. Whose graphs are related to the graph of f of x equal to x. And remember, this would be referred to as the parent function. Okay, so now I'm going to explain how to compare graphs of linear functions with respect to the parent function. Okay, so if I give you g of x equals x plus b, I can label this graph as g of x equal to x plus 2. And this graph would be g of x equal to 1, 2, 3, x minus 3 because it shifted down 3 units. And for the other one, it's plus 2 because it shifted up 2 units along the y-axis. Okay, and now we have the parent function, and this would be referred to as, we'll use f here, f of x equal to x, and I got this from here. Okay, and let's analyze this. The graphs have the same slope, one, 1, 1, but different y-intercepts. Graphs of this family are vertical, translations of the graph of f of x. And then when you have the case of g of x equal to mx, where m is positive, meaning the slope is positive, we can, let's see, first label the graphs. For this blue one here, we can again let that be the parent function f of x, which equals to x. And as the graph rotates to the right or becomes flatter, I'm going to label this as g of x, then you can see that there's a vertical drop of 1 unit, and you shift -2 units to the left, and you have a slope of half x. And same thing for the other one. 2 units up, 1 unit to the right, so your slope would be 2. So this would be g of x equal to 2x. So here the slope changes. The graphs have, again, different positive slopes, but the same y-intercept. Graphs of these family are what we call vertical stretches or shrinks of the graph of f of x equal to x. And we can simply say or describe this as a dilation of the family or of the parent function f of x equal to x. Now when we have g of x equals to mx, where m is negative, then the graphs will reflect about the x-axis. So what do I mean by this? Let's first label this graph as f of x equal to x. Okay? And let's label this graph to be g of x equal to negative x. You see, go down 1 unit and then shift right 1 unit, so the slope will be -1 over 1, so -1 here. And the other one, g of x will equal to, let's see how many units from the origin. It's -3, and then 1 unit to the right, so your slope is -3x. So let's analyze this again. The graphs have different negative slopes. You got -1 here, and you got -3 here. Different negative slopes, but the same y-intercept. In this case, 0, 0. Graphs of these family are, again, what we call vertical stretches, or shrinks with reflection in the x-axis of the graph of f of x equal to x. So as you can see, This is the parent function, and this red graph here was flipped about the x-axis. So treat this x-axis like a mirror. Part A, guided practice. Evaluate the function when x equals -3, 2, and 4.5. So when f is -3, I'm going to substitute -3 for x. 5.2 times -3 is -15.6. And -15.6 minus 4, -19.6. And now I have f of 2, 5.2 times 2, 10.4 minus 4 is 6.4. And then we have f of 4.5 and 5.2 times 4.5. Okay, so is 23.4 minus 4, so we have 19.4. And here we have h of -3 equals 8.5 minus 10 times -3. So -10 times -3 gives you 30. So this is 38.5. And then h of 2 . Okay, so here's -20. -20 plus 8.5 get -11.5. And then the next one, h of 4.5, 8.5 minus 10 times 4.5. And here, this would be 45, -10 times 4.5. Okay, so we get -36.5. Part B, for the given function, find the value of x so that the function has the given value. Okay, so we have to find out what x is when we're given what f of x. So substitute -7 in for f of x. Set that equal to ax plus 9. Then subtract 9 to both sides to get -16. And x would be -2. And for this one, we do the same thing. Substitute 26 in for p of x. 14 minus 4x. And then subtract 14 to both sides. Cancel. And then 2, 12x equals to -3. Part C, graph the function and then compare your graph to the graph of f of x equal to x, which is the parent function that goes through the origin. So here you have a y-intercept of +3 and g of x equals to x. We have to shift 3 units up. So we're going to start at the y-intercept 3. And then since the slope is 1/1, I'm going to shift 1 unit up and 1 unit to the right to find my other point, which is 1, 4. And I'm going to connect my dots. Okay, and then how I'm going to compare this, I'm going to have to write a short description. So this graph here the graph of g of x is the graph of f of x shifted upward 3 units. And of course, you can write this in your own words. You don't have to follow the same exact wording as I have here, just as long as I can understand what you're trying to explain. So let me draw the parent function, which is, this is f of x equal to x. So it's shifted up 3 units. Okay. Okay, and for h of x equals 2x, we know the y-intercept begins at 0, 0, and our slope is 2 over 1, so I'm going to shift 2 units up, 1 unit to the right, and 1, 2 will be my other point, and I can connect the dots. Let me redraw this. Okay, so this would be h of x equals to 2x, and my parent function will be here. This would be f of x equal to x, and what you can write is the graph of h of x is a dilation, or you can say vertical shrink. Okay, let me write that down. Vertical shrink of the graph f of x using a scale factor of 2. Now I'm going to add something here. What if I give you g of x equal to negative 2x? Then my graph will be flipped or reflected around the x-axis compared to the red one. And to describe this, we write the graph g of x is a dilation of the graph f of x using a scale factor of negative 2 with a reflection of graph f about the x-axis. So again, repeat. This is the mirror. The g of x was flipped around the x-axis to mirror h of x. Okay? The number of hours people in the United States spent using the internet each year from 1998 to 2001 can be modeled by the function where x is the number of years since 1998. So you need to count 1988 as year 0. Be careful. Okay, so part 8 wants you to graph the function and identify its domain and range. So I'm going to recopy this function here. F of x equals to 26.4. Apologize for this typo. X plus 54.4. Okay, and you will know that this is the slope. And this is the y-intercept. And with this two pieces of information, we can graph. So I'm gonna roughly plot the y-intercept around this point. Okay, a little above 50. And I'm gonna take 54.4 and add 26.4 to find my vertical shift. So 80.8, that's probably around here. And then my denominator here is 1, so I only have to shift 1 unit to the right. So your point should be, your second point should be about here. And this would be 180.8. And this one would be 0, 54.4. And I'm going to write this down. 180.8. And then we can graph. But I need to stop at 3 because it's only from 1998 to 2001. Okay, and then I need to figure out what's my y value. So I need to substitute in 3 for x. Okay. So we have 79.2 plus 54.4. That gives you 133.6. So this y coordinate here would be 133.6. And now we can write our domain and range. The domain would be 0 inclusive, okay, and 3 inclusive. Range, so here 54.4 to 133.6. Okay, and that would be our answer along with the graph. So 133.6. I should erase this a little bit because it doesn't touch 150. About here. Maybe I should fix my graph. So roughly, okay? And part B, find the number of hours that people spent on the internet in 2000 and explain. Okay, so we know the year 2000 corresponds to year 2. So we can plug in x2 for x, and that would be 26.4 times 2 plus 54.4. And then we do the math. 52.8 plus 54.4. Okay, and we have 107.2 hours. Okay, and part D, when did people spend about 120 hours per year on the internet? Explain. So 120 hours, then we need to let this be f of x, right? So we need to solve for x now. How many years? Okay, so then we can subtract 54 to both sides. 54.4, sorry. Okay, so 26.4x. Subtract this. We should get 65.6. And then x would be 65.6 over 26.4. 656 over 264. Okay, and then if you simplify this, you should get 2.5 hours. Okay, let's concludes our lesson.